All right, before we were talking about proportions, scale factors, so now we're going to move on to similar triangles. So let's get started. There's some more theorems and postulates to prove that triangles are similar. And remember that similar means congruent angles in proportional sides. And the symbol for similar looks like that little wavy line, but it's actually similar. All right, so let's get started here. So the postulate is, the first one is angle, angle. So you have to have two pairs of congruent angles. So your angles need to be congruent. If the two angles are congruent, then you know the third one's going to be congruent. But here, this is congruent with that one, and that's congruent to that one. So since we know that these are going to be the same, because it's all going to equal 180. So you can prove that they're going to be similar if they have two angles that are congruent. All right, the next one, now this is side, side, side for similar. Okay, now corresponding sides have to be proportional. That's very important if it is similar. So I color coded it here for you, but remember they all need to equal the same thing. So 28 over 14 are corresponding sides. That needs to be equal to 32 over 16, and then 36 over 18. So as long as they have the same proportion, then they're proportional, then you're good. All right, and then here you have side angle side, and again, two pairs of sides are proportional. So the two pairs of sides are proportional, and the angle between them is congruent. So again, proportional, proportional, and the angle between them congruent. So if you have that, then you can prove that it is similar using side angle side. All right, so now we need to figure out if they're similar. So remember, similar means proportional sides, congruent angles. So two pairs of sides are congruent, so their ratio must be the same. So let's go ahead, let's get started to prove this. So I did the little color coding for you. So notice this is congruent to that. Well then, if these two are congruent, then this side must be proportional to this side. So you can actually use this going side, angle, side. So are they similar? Yes, and we know that using side, angle, side. All right, the similarity statement is triangle RST. So here you've got RST is similar to triangle WSX. And we know that because two of the sides are proportional and the angle is congruent. And you don't need anything else. All right, so what you're going to do is you're going to do this one, but here's your hint. Set up a proportion. I already color coded it for you. And if you did this correct, your answer should be yes, because the side, 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 and then you set up similarity statement. All right, let's do this backside, or the second part to this. So for this problem, we need to identify the similar triangles and find the variables as indicated. So in this case, we are looking for AC. So we're looking for this guy. That's the length. So we're looking for whatever this total amount is. So let's get started. So for this, first we need to figure out what triangles with the similarity. So I know, let's just say ABC is similar. Now let's try to figure this out. Okay, I know C and E are congruent. So since I wrote C here, I need to write E third. And I know B is congruent. And since I put B here, I have to put B here. So then that leaves that D and A are going to be congruent as far as the angles. All right, so now that we've got the angles are congruent, now let's see if the sides are proportional. So set up a proportion. So we've got 15, which I said corresponds to 12, because EB corresponds with BC. And then I said that the next part we need to figure out is ED and AC. All right, so let's go ahead and let's solve that. So again, remember, whenever you're multiplying this, don't forget to put everything in parentheses. And now let's solve for x. So you should get okay. Divide by 3, x is going to equal 15. So that's one part, is we know that x equals 15. Okay, but now we're not done. Now we got to plug in wherever x is, we have to substitute it in here because we're looking for AC. So now, there you go. That's what it's actually looking for. All right, so make sure you solve for x first. Then once you solve for x, it's asking for this side, so you have to substitute in here, and we know AC is 16. All right, so for number 2, you're going to set this up and you're going to determine which side's the similarity statement, and then you're going to figure out solve for x, and then you're going to solve for, in this case, JL. So first you need to solve for x, and then you need to solve for JL. All right, so you're going to go ahead, you're going to try this one on your own. So again, similarity statement, set up a proportion, solve for x, then solve for JL. And that's how you do similar triangles. So make sure you understand those in setting up your proportions.